Okay, so from today we are going to learn the Pico mostly based on different project. For the first part of this, today I will show you how to use digital input and output in the Raspberry Pi Pico and MicroPython. For doing this, we will try to blink an LED and also we will try to have some input using a button so that we can turn on the LED using that button. For doing that, you need a resistor, you also need a LED, you also need a button, and you also need some sorts of jumper wire or connecting wire for connecting the LEDs. Okay, let's first try to see the circuit diagram and connect the circuit accordingly. Alright, so this is the pinout for Raspberry Pi Pico board. It has 26 GPIO pin. That means we can use 26 pin as digital input or output out of this total 40 pin. And all of the digital pin is of 3.3 volt. That means if it gives some output, this will be 3.3 volt. And if it wants to read something from the outside world, it will read 3.3 as digital 1 and it will read 0 volt as digital 0. But in practical, sometimes this value may be fluctuate. For example, if we give some input as 2 volt, that might be read as digital 1. So we need to be careful, but it is a good practice. Always try to make the voltage in the correct level. But if you try to input some voltage which is out of this range, for example, if you try to read 5 volt using some source of this digital input output pin, then this Pico board might be burned. So we need to be careful. We cannot give more than 3.3 volt as digital input for this Raspberry Pi Pico board, and as an output by default it will be always 3.3 volt. Having said that, let's try to connect an LED in the GPIO 16 pin. So it will look like this in a real circuit. So let's say this is our LED and this is connected to the ground. So this is the LED. We need to find the value of this resistance. So for finding this one, we need to know about the current rating for this LED. In most of the cases, the current rating is 20 milliampere, but sometimes there might be different ratings of the LED. So we need to be careful about that. So to find about this resistance, the output voltage of this Pico is 3.3 volt and there will be a voltage drop around 0.7 volt across this LED. So you can write the equation for R like this. It will be 3.3 minus 0.7 over 20. So you will find a range you will find the resistance value by using this equation. So if I try to calculate this one, this will be, okay, consider it as a milliampere. So anything greater than 130 ohm is perfect for this one. But if we connect the resistance of very high value, then LED might dim a little bit. So just be careful about this one. So for this today, I'm just chose 220 ohm in my case. So it will be 220 ohm resistance for this one. So I think the circuit diagram is pretty simple and it's very easy to choose the perfect resistance for today's project. Now let's connect the circuit in the breadboard. Okay, so first we need to connect a resistor from pin 16, as you can see here. So let's connect it. So this is my pin 16 and I'm connecting a resistor to this point, and from this point I need to connect the LED. So you need to be careful about the anode and cathode of this LED. So I'm connecting this positive terminal here and this negative one to the ground. So now I need to give the ground connection because here in this line there is no ground connection yet. So I will use Pico ground pin. So this pin 8, okay, so this ground is very close. So this is a ground pin, I can use this one. So I'm just trying to use this one as a ground pin. So now the circuit is connected as described here. So I connected GPIO 16 through a resistor to this LED and I also connected the ground. Okay, now let's do the coding part. Okay, so for doing the code, I already opened a new file into the Thony and let's just confirm your board is connected to the right port of this one. So if it's connected to the right port, you will see the file system here. So now let's just save this file by clicking this save as. So it asked where I want to save this file. So because we will run the code into this board, so I'm choosing Raspberry Pi Pico and let's just give it a name, digital IO. So I save it and it's asking me about the extension, so I click it yes. So let's just import the machine. For machine we can import the pin because we only need the pin, and then we can also import the U time. So it's good to use U time with MicroPython. You can also use the time, so there is two, but it's good to use the U time. So I'm using the U time, and now I'm declaring the LED into pin 16 because I connected my LED to the pin 16, and then it will be a digital output, so I need to declare it as an out. So the pin.out declares the pin 16 as digital output. So if we want to turn this LED now, let's just do it, but before that we can create a while loop so that it runs continuously. So if I now set the value of this LED as 1, the LED will be turned on. So let's just run it. So here you can see after running this code, the LED keeps turning on forever. So let's try to turn it off by the code. So if I set this value as 0, this LED should turn off. Let's run it. Okay, even though I write the code for turning off this LED, we can see this LED keeps turning on forever because this while loop will run continuously. So it will turn on the LED, then it will turn off, again it will turn on, and then turn off. So this cycle goes on very fast. Our eyes cannot make this differentiate in between this turn on and turn off. So for seeing this one, let's try to give some delay. So we can use this sleep function from the utime library to give the delay. So I make a delay of 1 second after turning on this LED, and if I run this on now, we still see the LED is not turning off because in our code we just make a delay after turning on the LED. So the LED turns on, then it keeps a delay for 1 second, then it turns off, but immediately it turns on it again, so that we cannot see this effect of turning off. So if we add another delay after turning off, now you will see the effect of blinking LED. So you see the LED is now blinking at 1 second interval because it first turn on, then have a sleep of 1 second, then it turns off, then have another sleep of 1 second, then it goes to the next cycle of turning on it again. So this cycle goes on. So if we just make this delay for 5 seconds, then the LED will be turned on for 5 seconds, then it will be turned off for 1 second, and after that it will turn on it again for 5 seconds. Let's just try to see it. So you see the LED is turning on for 5 seconds and it will be turned off for 1 second only. So by using this sleep function, you can like make any delay in between the digital output system. Okay, let's now try to connect an digital input pin to the digital pin 15. So if we connect a switch or a button into the digital pin 15, the connection diagram will look like this. So this is the this is the switch, and one part of this switch is connected to 3.3 volt and another part is connected to this GPIO pin 15. So if we close this switch, then this pin 15 will read this 3.3 volt as digital 1, and if we open this switch, then this GPIO pin 15 will read this input as digital 0. So let's just first try to connect this one and try to see what happens when we press the button. You just need to be careful so that you cannot exceed this input voltage more than 3.3 volt. If input voltage is more than 3.3 volt, then the pin may become fried. So just be careful. If your input is more than 3.3 volt, then use some voltage shifter or voltage divider rule to convert that voltage into the range of 3.3 volt. Okay, so I connected my button to GPIO pin 15 and I connected another part of this button to 3.3 volt. So now if I press this button, this 3.3 volt will be passed to this GPIO pin 15 as I just show you in the picture. So let's try to make a code for this. So I name this as a button and I attach this button to pin number 15 and I declare this as an input pin by declaring this pin.in. So my button is now as input pin. So let's try to read this button. So if the button is pressed, that means the button will be connected to 3.3 volt. So that 3.3 volt is actually the digital 1. So I can say if button dot value equal 1. So that means if the button is pressed, then the value will be 1. So in practical it will be like 3.3 volt, but as in digital domain we only know 0 or 1, so it will read as 1. So this 3.3 volt will be read as 1 in this case. So if this value of the button is 1, then we can say button pressed. Okay, so let's try to run this code. So I run this code and I'm just pressing this button. Okay, so you see I just press the button, but you see there are lots of buttons pressed printed in the console window, but I just press this button one time. So if I hit this button another time, you see there will be lots of buttons pressed. In fact, it just keeps taking this value. So let's try to figure out why this is happening. So in our case, we are trying to read the 3.3 voltage. So this is simply like this. So we connected this button to the GPIO pin 15 here. So let's say this is the pin 15 of the Pico board. So this is the Pico board and we connected it to this 3.3 volt. So when we like close this button, theoretically it should look like this. So it should go from 0 volt to 3.3 volt to this GPIO pin 15. So it should go like this pure kind of square wave, but this is a kind of mechanical thing, so it will be like some sorts of zigzag like this. So if you just close this button, there will be lots of zigzag. So this pin 15, it will read there are multiple button press. Even though we pressed it for one time, it will be like a zigzag, so it will read it as a multiple input. So that's why we see this button pressed for multiple times. So for solving this, let's try to add some delay into this one. So for making the delay, we can use this qtime dot sleep. So what this delay will do is, like I can let's just set up it for 100 milliseconds. So if I give it 0.1, that means it's for 100 milliseconds. So what the delay will do is, like, as long as it detect one button press, it will stop reading anything for 100 milliseconds. In this way, it will remove this effect of this zigzag. So this zigzag is especially called the debouncing effect. Sometimes it's called the debounce. So it's called the debounce effect. So for removing this debouncing effect, we can just make a delay. So let's try to see what happens. So with 100 millisecond delay time, let's try to see what happened. So I run this code. Eventually, currently I'm not doing any button press, it's reading the button is placed. So this might be for some sort of noises from the external environment. Also, there is another big issue we need to solve. This is called the floating point. So let's just try to see it. So the floating point issue is, we are connecting our Pico pin 15 with this button, and this button connect this pin 15 to 3.3 volt. So this is the usual case, and when the button is not pressed, then this pin 15 is neither connected to 3.3 volt nor connected to any 0 volt or any other source. So it's kind of floating. So and this floating pin might be affected from some external noises. So to remove this one, we can connect a resistor to the ground. So now if the switch is not pressed, then this pin 15 will be connected to ground. We are connecting pin 15 forcefully to the ground when there is no button press, and this is called the pull down resistor. So this is called pull down resistor. We use this pull down resistor to remove the debouncing effect along with this delay time. So we need both. So we need to solve this debouncing problem from the hardware using this pull down or pull up resistor, and we also need to add some sorts of delay function in our cases. So now if we add this pull down resistor, when the button is not pressed, it is connected to pin 15 is connected to the ground, and when the button is pressed, then this current will flow through this one, and pin 15 will be connected to this voltage source. So in this way, we can remove the effect of, for example, we can see the button is keep pressing even though we are not pressing the button. So this is because of this floating point. Also, we already seen if we press the button one time, the Pico detected the button press for multiple times. This is because the debouncing effect, as I have already discussed, this is for this debouncing effect. So if we add some sort of delay function, it will remove this debouncing effect, as well as with this pull down effect, it will remove this debouncing effect, also the floating point issue. So for adding this one, we can declare the input pull down here, because this Pico pin has some internal pull up and pull down resistor. You can also connect pull up or pull down resistor externally, but as the Pico has already the internal pull down resistor, we can just directly use it here. So you can use this pin dot pull down. It will automatically connected the pin 15 to the ground through this pull down resistor. So after doing this, if I now stop and run this code again, you see without pressing, nothing is being happened because the pin is not in floating condition right now. It's connected to the ground through the pull down resistor. So if I now press this button, you see it's detected the button press, but is for every one button is detected the button press twice. This may be because of this delay, so we can just change this delay to 200 milliseconds. Still there is the problem of debouncing, so I increase the delay time. And if I now run this one and press this, okay, it seems like it now working perfectly. So with 200 millisecond delay time and this pull down resistor, I'm solving the problem of debouncing and floating point issue. So this is all for digital input and output, and in the coming videos I'm going to talk about analog input and output. So just before making the in, let's try to turn on this LED by this button press. So for doing this, what I can do is like I can just add this LED dot value 1. So I'm making this value of the LED as 1. So if I run this program again, now if I click this one, it will set this value of LED as 1. You see the LED turn on, and if I press it again, nothing will happen because every time it's try to set the value 1 and it's already blinking, so it will not blink again if I press this button again and again. But you see the button press is being green. So what I can do is just you guys can try just to turn off this LED with one button press and turn on this LED with another button press. So using a single button, you can try to simulate the condition of turning off and on this LED. So if you have any problem, you can comment on my YouTube inbox. You can also send me email into my email. Thank you.